This is a presentation of an application that I wrote along with my master's thesis, which was called Effective Volumetric Sculpting for Focus+Context Visualization, utilizing implicitly defined surfaces and VR on demand. When visualizing volumetric data, classification alone is not enough in many cases because of occlusion. Segmenting the volume and then choosing rendering qualities within each segment is very beneficial. Not only does it reveal hidden data, but it allows for additional visual tools, for instance, Focus+Context Visualization. In many circumstances, manual segmentation through sculpting is the best or sometimes only option. How can we sculpt in the best way? In my thesis, I'm using an implicit surface-based approach. A sculpt can be built additively using blending geometric objects. This allows the user to start with a context render and then add focus piecewise into areas of interest. Each piece of geometry is stored in a list, and its attributes can be modified at any point in time. I call this dynamic sculpting. Rays are already used to define the start and end of segments, so it is optimal for direct volume rendering by ray tracing. The geometric objects that comprise a sculpt are defined using signed distance functions. And then we can use an iterative method called sphere tracing to find the solid segments enter and exit points. And then we can perform direct volume rendering over this segment. The segmentation scheme was originally based on the idea, how can we segment in a way that utilizes VR peripherals in the best possible way? I came up with an interaction scheme called VR on demand, which means that the software is a normal screen, mouse, and keyboard-based application, but it allows the user to enter VR at any time for any period of time. And this gives the user access to immersive view and VR sculpting on demand. And dynamic sculpting plus VR on demand allows for a best of both worlds dual space sculpting, which means that you can make a rough sculpt in virtual space and then fine-tune it in standard space. Okay, so here we have our context rendering of the full dataset. And right now it is using a first hit style context rendering with texture projection in the XY plane. And we can change to maximum intensity, which has a semi-transparent look and will show you the areas of interest immediately. And also we have a contour, which is even more transparent. So, and the crop of the context you can change in case your data set is much bigger than the area you want to examine and explore. You can change the crop settings, and also you can position your data within your crop, like your context crop, in case your data isn't centered around the area you're interested in. And you can also rotate in case the rotation is, in case your data isn't rotated in the way you would like. And this rotates around the center of the crop box. Okay, so yes. And we will load a different. So here are some preset data sets that I have in my file folder. Okay, so now let's say we would like to focus on this organic structure. I will use my inner focus for this now. And so I will add a group, and within this group, I can add a new box. And this is a meta box. I can position it around in my data. And within this meta box right now, I am using this transfer function to classify the data. And so it will pick out all the data, right now I'm selecting the data which has these values. So these are the data values of my data set, ranging from low value to high value. And so now I can select my the value. I'm selecting a region of these data values, and I'm telling it how to render it. So I can select color, for instance. And okay, so I would like to use my meta boxes now to try to hug this organic structure as tightly as possible. So I can place this, I can scale it, I can also rotate it around. So these are the axes I select for both scaling and rotation. So maybe I would like it to be a little bit more round. So here you can select the roundness of the meta box, ranging from totally cubic to more spherical. And I will position it there. And okay, now I would like to, I also have to position it from above, maybe rotate it a little bit like this. Okay. So now I would like to subtract some parts. So I will add a new group. Within this group, I will add a new box. And this box now I will, so first of all, these two shapes are now combining to make this sculpt for the inner focus. So you can see this contour. It shows the contour of the total sculpt that I have made for the inner focus. And using my, let's say I'm just gonna make it a bit smaller. And now if I use my smoothness, you can change the radius of the blend between this shape and all the shapes above it. And this is very good for encompassing organic structures. So you can also make it subtractive. So now this shape is subtracting away from the total sculpt for the inner focus. So what I want to do is position it here to remove this, to make the sculpt hug the organic structure as tightly as possible. And I will add one more box. Let's see. So now I want to remove this part. Something like that. And finally, I would like to get this part as well. And I will rotate it and make it subtractive. So now we have a very tightly hugging sculpt, a segment. We are tightly hugging this organic structure with our segmentation. And now we can use our classification, and it will only be classifying the data within the region of this segment. So if I put back the context, you can see you are rendering the rest in a context manner, and within this segment you are using a more focused style of rendering. And what I can do now, I can, for instance, lower the opacity of the context to make it easier to view the focus. Or you can also use this ghosting style rendering, which will totally clip away anything that is occluding in front of your focus, which can be very useful in some settings. And so right now we have these groups. We have these two groups here. And you can also turn them on and off. So you can fill a group with, so let me just make a new group there. I can fill this with a selection. Let's say I want to do something here in the brain region. Let's see if we can. So now we have the brain there. And I can color it maybe this. Okay. Now I can turn it on and off by turning the group on and off. And also, you can rearrange these groups. So let's say I want to move this group up in the hierarchy. Then you can see it starts to get subtracted by the shapes in this group, like this shape. This is a member of this group, and so it's hierarchical. So it will first, right now, it will first do this, add this to the sculpt, and then now it will add this to the sculpt, and then finally it will subtract from everything above. So if I move this group back up again, now I am adding this sculpt, then I'm subtracting from it, and then I'm adding back in this sculpt. So it is working in an ordered way, so you can subtract first and then add back in. So if I add something here, this will be added where I was subtracting. But if this is added first and then now I'm subtracting afterwards. No, this group is subtracting from that as well. So it's hierarchical in that sense. Okay, so let's take a closer look at the transfer function. So first of all, you can define regions of your transfer functions using these points, and you can add and remove them by clicking the right mouse button. One point, when you move it around, so you're selecting the mid value of the region and the opacity of the region by moving it around in the histogram. You can also change the range of the region, so you can have a very narrow range and you can have a very wide range. And then, let's see, each of these regions, you can select the gradient magnitude of for each point that when you're iterating through your volume, you can select which data values will contribute to the coloring, and you can also select them by their gradient magnitude. So if you want to get more surface, or maybe only the surfaces, you can change these values. So here, all gradient values below this are ignored. Every gradient, all the gradient magnitude values above this is rendered as normal, or every data point that has a gradient magnitude above this is rendered as normal. And between these, there's an interpolation from 0 to 1 to get a bit more smooth, to be able to adjust it to look a little bit more smooth. So now you can see you're only getting this surfaces. And you can also flip this, and now only the points that has magnitudes lower than this are rendered as normal, and every point that has gradient magnitudes higher than these are ignored. And then there's an interpolation between these two. So now you can see you're getting the opposite, like the insides of the surface. And you can combine these. So let's say you want to color the insides in red, and then you can use these, for example, with a bit higher magnitude setting in the same region. And now you get, you can select the color of the surface of your organic structure and also its insides. And so if I maybe add a box now, let's see here, and I make it subtractive, and I can remove the context a bit. Now you can see the insides are rendered in this color, and the surface of this organ is rendered in this color. And also, let's see. So each point, the color settings that you can set. I'll just choose this one. Okay, so each point you have a bunch of material settings. So first of all, of course, you have the color. So you can select the color for the rendering. Or you can also use texture, and you can select. Here I just have some organ and bone colors, and I also have this, so you can see. So you can use any texture that you would like, and it's using a triplanar mapping. Okay, so and I just put this back, and you can also combine color and texture. You can use Phong shading, which has the normal Phong attributes. Diffuse, specular, it's not so easy to see. Maybe if I make it white, maybe. Okay, we give some metallic coloring. And you can also use a matte cap, which is nice if you have some material presets that you would like to make. And you can, it's a bit faster to select maybe than having to specify color and Phong shading, Phong shader settings. And then I also added normal texture, so you can add normal texturing to your shader. And this is also triplanar mapping of the normal texture, like the color texture. And you can also select normal texture. But I mean, this isn't very useful, I guess. Maybe you can find some use for the normal texture. Okay, so now let's have a look at some of the VR functionality of this application. So first of all, we have this broadcasting window where you can see whatever the person in virtual reality is seeing. So he is now having this access to immersive view on demand, so he can just put his headset on, and he will be viewing his data in VR. And now let's try to add a sculpt, or try to do some sculpting in VR. So in VR, you can rotate your scene using this hand controller, and you can move the shape around with this hand controller. So let me just turn off the context a little bit. Okay. So you can scale your meta box, of course. And right now I'm working with an outer focus, which is sort of like a in between context and inner focus. So I would like to have some bit more focused contextualization of the immediate surroundings of this structure. I can use, so I have this 3D cursor available, and I can use it as a presentational device. I can use it as a presentational device, so I can annotate an area of my structure while talking about it, for instance. But also what this does is, if I add a new meta box into my scene, it will be added centered at that 3D cursor. So if I add a box now, it will be centered there. So let me just add a contour to this. So now, yes, so if I have all the same options available in VR as I did in the standard space. So I can, of course, scale it. I can adjust the roundness of my shape, and I can also adjust the radius of the blend between two like the meta shapes in my sculpt. So if I'm just, let's see, I'm gonna make a subtractive part here, and you can also make it subtractive by a button press. So if I'm just, let's see, I would like it to just show the top part like that. Okay, so now I have made this selection or this segmentation, and now I can take off my VR device, and I can continue in my standard space, and I can fine tune my whatever I did, right? So I can fine tune my meta boxes. So maybe I would like the rotation to be a bit more accurate. I can fix it here. Yes. So now I'm just going to classify the vertebrae of the fish within this outer focus, something like that. Let's see, I'm just going to add some color to it. Maybe green, actually. And then there, maybe I'll make this different shade of green, maybe. Something like that. And then I can put my context back, and I have this. And if I take away the contour of both the outer focus and the inner focus, let's see, like that. And then maybe I want to make this a little bit less opaque, so it's a bit transparent. So it doesn't occlude my inner focus that much, but it's still providing a bit more focused context than maybe this context does. And I can also reduce the opacity of the context a little bit more, maybe something like that. And then you have this inner focus, and then this outer focus, which you can define as more a mixture of a context and a focus. And then, of course, you have your context rendering. Okay, so now let's have a look at the different options you have within each group. So in the context group, you have the opacity slider. And you also have this march distance, which you can use to set the fidelity of the direct volume rendering. So a high distance gives you a worse fidelity, but it heightens the frame rate. And you have these, yes, and also you have the crop contour to visualize the crop, and you can also visualize it with a surface rendering. And this you can also do in your focuses. So you can, for instance, you can change the opacity of your focus. And you can also adjust the marching distance. Now let's see at on the inner focus. You see that fidelity gets a bit better when you lower this, and much worse if you heighten it. But it also, of course, it will affect the frame rate. Then we could visualize our segment with a contour, and we could also visualize it with a surface. This can be useful if you want to see exactly how your segment looks like. And then we also have this trace depth. So if I turn this on, and I'll turn this off a little bit, and now you can see this is occluded here. So it will only perform one sphere tracing segmentation. If I take this up, you can see it will segment, or it will sphere trace through this and then through this part of the sculpt. So you can change the trace depths to just for optimization purposes. Maybe you need to put it there. This will give you a better frame rate, but of course it will not give you as good fidelity. And you can of course change this. And I found that a trace depth of 3 is usually more than enough for most needs. Okay, so now let's have a look at the slice view. So when you turn on the slice view, you will get 3 slices: a top slice, a side slice, and a front slice. And you can adjust the position of these slices, and you can also let's see, to make it easier to visualize exactly where your slice is, you can use cropping of the contexts, and then it's a little bit easier to see exactly where you're slicing it. So, okay. And then let's slice the top one, maybe there. And let's take the side slice, something like that maybe. Okay. So these slices, this slice view will let you make some even more fine-tuned configurations of your segmentation, right? So what you can do here, if you have your sculpt, you can select your sculpt piece, and then you can, in sculpt view, you can move it around. So let's say you would like you are not sure if you're including everything you need to include in your segmentation. you can use the slice view to get a very detailed view. So maybe here you see, oh, I want to make sure I get all of this in my selection. So you can adjust it here in your slice view. Yes. So of course this is very good for fine-tuned segmentation, and sometimes you can't really see some area of interest that good in your context rendering, and sometimes it's easier to see in your slice view. So for instance here, it's easy to see the brain. So if I want to add a box, I would like to add to my to see the brain here. I can make sure I am encompassing everything here by looking at the slice view. Then of course I have to find the correct density value for this organic structure afterwards. And then you can turn off your slice view again and continue in your normal view. So one big challenge when using VR peripherals is to get a good frame rate to optimize your rendering. So what you can do is you can use a foveated view, which means you have an inner quad and an outer quad. So here I just have this so to visualize this for you. So you have this inner quad here, which has the high fidelity rendering, and then outside of it you have a lower fidelity rendering. And even though you don't have eye tracking, this actually works quite well just with a foveated view, or like a high fidelity quad in the middle, because you're usually looking straight ahead in your VR HMD anyway. So this actually works quite well. You don't really look into the periphery of your HMD that often. So, and you can also adjust this quad size. So now by adjusting this, you are adjusting the area of high fidelity, with the low fidelity area being outside. And maybe you can see a little bit of a change as I adjust it. I'm not sure if it's so easy to see here in this broadcast view. It's easier to see in VR in your HMD. So that's one thing you can do to get a better frame rate. I also have this ray march step distance depending on distance from center of your view. So as you go further away from the center of your view, the ray march step distance becomes higher. And this, of course, also affects the fidelity. And you get highest fidelity in the middle of your, or in the center of your view. But this doesn't work very good, because as you can see, you get some really, really bad artifacts. And you can also see it here. Maybe it's easier to see here. You get these rings. You get this ring artifact, so this didn't work. But I thought it was interesting to try anyway. Not very successful, I guess. And then also, I added a fake AR type of screen. So, okay, in AR, if you're using augmented reality, you can view your, um, you can have an immersive view and access to your mouse and screen and graphical user interface simultaneously, right? But what you can do, you can just copy the rendering of this view, this standard view screen into your VR environment. And now I can use my mouse from inside virtual reality or from within the virtual space uh, and perform operations in my graphical user interface. Okay, so of course you can save your scene and you can load a scene. So um, let's just try to load something here. So then you load a scene with everything, all your settings and everything, right? Um, so yeah, you can load and save your scene. Okay, so I also added this rendering functionality to my application. So because lowering this march distance here will slow down your frame rate a lot, but maybe you want a high fidelity screenshot of your visualization. So instead, you can just do it. So this is here you set this marching distance for the one-time frame rendering instead. So you can set this to maximum fidelity. And also I have this size multiplier. What this does is your screenshot will be this window, the size of this window, multiplied by this. So it will be 4 times the size in each axis. And then you just push the rendering and you wait a few seconds. And there, okay. And then you have your screenshots in your on your hard disk. And as you can see here, this is the size of the final of the rendering, and it has a very nice fidelity. And you can also set it to be transparent, which will make the black background transparent instead. And this is what I have been using in my thesis for the many of the pictures. So I also have this help uh, options. And what this is, the help line is just this small text here, which just gives you an overview of your controls. So you can, or this is for the camera controls. And you can see here, holding down Shift on your keyboard will give you the operator control, which is the meta box controls. So you can change the position and rotation and this and scale it. And then you also have your cursor control, which is the 3D cursor. So you can also use the 3D cursor in your standard view. And here's the list of controls you can perform on it. So that, and you can turn this text on and off if you want. The tooltips, I mean, that's the tooltips for all the GUI options. You can also turn it off if you want. And then these are just some things that I have been using while developing. It's just some prints, and it will print to the command prompt. So if I turn this on and off. Something else that I was experimenting with was points segmentation. So, let's say you have 40,000 points in this area, and you would like to color them, or you would like to adjust their how you render them by which segment they are inside. And what I'm doing here is that each point is just using this segmentation querying. It's just querying the space for which segment it's inside, and then coloring the point based on that. So it would, so with full opacity on the context, it would be totally, these would be totally occluded, right? But you can lower the opacity or even turn it off completely like this. And you can also have an inner focus and your outer focus. And one thing that was really interesting with this was that you can interpolate the points coloring between the context and let's say the outer focus coloring here, based on the points containment within the segment. So it's based on the distance from the surface of the segment. So if we turn this down, you can see only the most contained points, or the most contained points have this coloring here. And so you can quickly localize the most contained points within each segment. So this could be an interesting use case for some, perhaps if your points, the more contained they are within some space, the better they are in some way, or the more optimal they are in some way. So this could be used for that. And you also have access to your point visualization and segmentation in VR. So you can put on your HMD to view the points immersively, and you can also add or you can sculpt in VR as well. So now I'm adding a new meta box. Yes, so you have all the usual options in VR as well. So let's say you have two separate data sets, one volumetric and one with points in the same space. And you would like to, for instance, select the points or segment the points based on segmenting the volume data. So since you can do both points and volumetric segmentation with the same method, you can do a multimodal segmentation. So let's say you have these points in the same space as this. And as you can see now, all the points within this focus, the inner focus, are colored in purple, and all the points outside are blue. And now you can control the rendering of the points individually outside the segment and inside the segment. So this makes it possible to segment a different data set or different type of data based on the volumetric data, for instance. Maybe it's not so easy to know which points are inside this brain segment, perhaps. But now you can segment the brain volumetrically, and then you automatically also are segmenting the points in the same within the same space. Okay, so some other functionalities that I added to my application. Of course, you can load any data set that you want from disk as long as it's a nifty file format. But I added this functionality which saves everything within the focus as a new data set. So it will remove everything outside the focus. So if I now open this data, this saved file in a different application. This is the MRICRO GL application. You can see you only have this segment. So let's try to just render it. Now you have segmented your data, and you can, for instance, maybe a different application does not support segmentation in the same way. Now you can segment it in my application and then import your segment into a different application that does not support segmentation. So that was all the functionalities that I wanted to showcase in this video. And then now I will end the video with a few good visualizations that I have made using my application. Thank you.